today to teach you a little bit about our university. I have been with Birmingham City University since 2016, initially as a BIM. I have been with Birmingham City University since 2016, initially as a BIM assistant.
You can put this in your pockets and then you can put this.
2018. And I'm also joined today by Chris Johnson from Willmott Dixon Construction. Chris has worked with us of our capital scheme, so he's really well familiar with our information requirements and will be able to give you a very good insight of what it takes to deliver those in the field. Okay, so just to start off with a little bit of an introduction of our timeline, where we are and where it all started. So the university has been on its route to digitizing its construction and facilities management database since the mid-90s, with an early adoption of a reactive maintenance system, essentially a ticketing system. That was followed by compilation of 2D space data across the estate in 2004, and our first official BIM scheme opened in 2013, the Parkside building, which is the home of the Faculty of Arts, Design and Media. What we consider to be the landmark of our development is the Curzon scheme, which was opened in 2015 and then later on extended with a phase 2 project by Willmott Dixon in 2017. So following the Curzon building, the university embarked on an intensive phase of development, working on 3 capital schemes simultaneously, delivering BIM on all 3, as well as a developer scheme, opening the doors to the Birmingham Conservatoire in 2017. And as you can see on that timeline, we started quite early on in the process, and we have extensive BIM database, and process was still evolving, so British standards and documentation still being developed as we were already working on our journey. What we're working on now, we're working on Steam House 2, which is a building spread over 11,000 square meters, a mix of educational, commercial, and incubation space. Stage 3 of the project is about to kick in with a scanned survey, a 3D scanned survey of the Belmont Works factory facade, which was gutted by fire in 2007. The university is restoring the building, as well as adding a new facility at the back. For this project, we are using new technology. We're utilizing BIM 360 document management to share models and drawing information centrally during the projects. So we are very keen on having this central link of information being shared during the project to allow central visibility, but also version control to be able to really track progress of modeling and the drawings at every stage of the project. We're focusing on the information delivery plan very strictly on this project, as well as roles and responsibilities to improve visibility and transparency. We have also got a new classification system that is now fully aligned to the SFG 20 maintenance standard, introduced by the Building Engineering and Services Association. So a little bit about why we do it. There are many reasons why we would want to build information modeling on our project. But above all, the university has a long-term interest in its facilities. As such, we're interested in the management of the whole life cycle of information. And we're interested to do this in a sustainable manner. We are interested to reduce the amount of information or the overproduction of information by sharing it centrally between the teams. We are also interested to reuse the same information that is used to design the buildings, to construct them, and then later on to operate them. And we are also interested in seeing that whole process being recycled during operations by reusing the same information and completing the cycle. And what we would like to really see is the ability to influence the design positively early in the process at minimum cost and with maximum impact. So when talking about building information modeling, well, a building information model is a pretty complex model, and it consists of all kinds of data sets. In a way, we view building information modeling as a complex system that allows us to link different kinds of data sets, and a complex information system requires complex information requirements. So looking at the building information model, a client needs to really think what it is we would like to receive at the end of the job. Is it just a 3D model? How would you like your asset information to link to your 3D model? How would you like your drawings to link to the 3D model? Well, what about testing and commissioning certificates and operational and O&M literature and documentation? So then we look at the second aspect of building information modeling, which is the how question, the modeling question. How is all this information going to be produced to give us consistency between projects, but also accuracy throughout the database? And this is by implementing a process, a specific process that needs to be followed, and also following some standards. So we're now looking at the new ISO BIM standard and what elements of that would suit our template. And the final aspect we need to consider really is the management aspect of BIM. It really is taking responsibility about who is responsible to produce what kind of information and when. So a complex information template needs quality controlling. It is, as I mentioned, a complex system, and setting out information requirements should only be done in a measurable way. There is little point setting out and asking for information if you're not able to verify that information. Because often, and what I can say is that bad information is worse than no information at all. And it may be the case that a spreadsheet is better than a complex, poor quality BIM model. So when we look at information and quality, we really need to consider what process we're going to employ to validate this information. So there are the two steps. There is the verification step, where we verify our asset information requirements and whether they meet our criteria of what we receive on the scheme. And then there is also the validation point. And this is a bigger process that is team-wide, and we work with our operational teams to look at the data we receive on a project, whether it is the right data, and whether it is in the formats that we would like to see. Okay, and we use classification in order to achieve consistency between projects. So there are many classification systems, and all come with advantages and disadvantages. The university does not use Uniclass, which is the BIM standard or the ISO implementation in the UK. We use NRM3, which is geared towards the operational life cycle of the building, and also towards maintenance. Okay, and that helps us get our data in a consistent manner, so group between projects. We work with many different delivery teams that work to different standards, and we receive a lot of different information. So without setting out all the complex information requirements that are difficult to execute in the field, we can use classification to group our objects, take them into our computer-aided facilities management system in a meaningful way. So, so why develop a complex template as such? Well, we're always focused on deliverables. We need to understand as a client what it is we are receiving at the end of the job, and what is the purpose of this deliverable, and how it is going to help us operate our buildings. So as such, we need to consider some key criteria during the project, such as roles and responsibilities, as well as what kind of standards we're going to implement. We work with a particular set of formats. We do not use COBie. We receive native Revit design files with manufacturer literature included in the models and asset information. And we also focus very closely on the information delivery plan. So we would like to see all the information that is shared on a project, not just the as-built information, but also information that is issued for tender, information that is issued for construction. And we would like this to be done in a central way to be able to track change and version control. And as mentioned briefly, we also use classification to present our data in a meaningful way for facilities management. Another aspect we need to focus, that was touched briefly by Hadir, is change management. There is little point working on receiving rich BIM information if that information is not going to be maintained during operation. And there are many challenges with this. But it is something that I have been focusing on in the last 6 months in particular. As you can see, well, an asset portfolio is at the heart of any quality facilities management template, so it is essential to maintain it during operation. So the way we do this is making our models available centrally on the cloud to be able to access by delivery teams. And we use our teams to update our models whenever we do a refurbishment, but not necessarily, the models are not necessarily used to drive change. Our teams would always go and measure on site. What is essential to us is to maintain a quality database that is reliable at any one stage of a project. So just a brief pause to introspect here, really. And so we have heard talks about BIM levels and what they are, and pretty complex templates. But what we really need to focus on, what are those templates aiming to really deliver? So focus on the outcomes at the start. I'm pleased to say my understanding is that the new ISO standard does not reference anything similar to BIM level 0. So the industry has matured. We're now broadly working at BIM level 1, where we're able to work collaboratively and share information. And we're really moving forward towards BIM level 2, which is to be able to deliver that information in a structured and meaningful way. Just to finish this part of my presentation, I recently did a comparison chart of where we are in terms of the industry standard and how we differ. Although we are very broadly along the lines of BIM level 2, because we started our BIM development so early in the process where the standard wasn't very well established yet, our template does differ from what is the industry standard, and there are small changes. We require native design files, so we receive our information with Revit files. Our drawings are limited to those files so that we can maintain them easily during operation. We use NRM3, which is not the ISO implementation of a classification system in the UK, but we find that is really helpful for when we actually get that data into facilities management. Yes, we use SharePoint as well to store our information with a combination of BIM360 to store graphical data. So yes, having completed 5 capital schemes and receiving a lot of rich BIM data, the university did not have a computer-aided facilities management system. So last year we procured Concept Evolution, which is a BIM-compatible platform. And integrations and rationalizing our data has been a big challenge for us and something that has taken a lot of our time. So when talking about integrations, we have to demonstrate that we are compliant as a client in terms of plant preventative maintenance, and the university uses the SFG20 standard, with which you may be familiar, which is very broadly those plant preventative maintenance schedules that are grouped based on criticality, the red schedules being those that we need to comply with in order to demonstrate compliance. And there are other schedules that have an impact on business and service, and some are discretionary. So part of our integrations and taking our BIM data from the models into CAFAN was needed aligning with the SFG20 standard. And the way we achieve this is by using NRM3. Just very broadly, at level NRM3 is structured in levels. At level 1, we can see groups of elements. Moving on to level 3, we can see building elements, which are then broken down into their systems at level 3, and components and specification at level 4 and 5. What we did recently is we extended our classification table to go to NRM level 6, which was introduced by the BESA. The BESA aligned their SFG20 data to NRM, and they found that the classification system needs to extend a little bit further in order to pick the right PPMs for our assets. So we now revised our NRM tables in order to comply with it. So looking at integrations, what was our priority was to create a digital twin of our BIM data that we can take from our native design files into our computer-aided facilities management system and be able to exchange data between the two bidirectionally, so that we can maintain a designer information in the designer models and facilities management information into the computer-aided facilities management system. And when talking about information, we talk about NRM in terms of classification and how we group our objects to be meaningful to our operational teams, and also a lot of manufacturer literature that comes from our Revit files. And all of that is linked to the SFG20 XML, which also goes into the concept FSI. So I worked really closely with our operational teams in creating a CAFM mapping template to help us really get our assets into concept in a meaningful way and cut out all the junk that can come from a BIM model. So we used NRM to specify our asset types, and we identified 4 types of assets. Grouped assets that could be using model data such as location, distribution board number, fire rating, etc., depending on how engineering would like to maintain the buildings. Individual assets, if an individual asset needs to be listed individually regardless of any other criteria, and also parent and child. So we went through the complete NRM table and classified our assets. and also links that to SFG20 scheduling. So when we did this, we started with our cursor building, and Chris will talk a little bit about that later. But we were able to then take our asset information from the models and run a dry test for our CAFM integration and really see how this data is starting to shape up and make sense in a meaningful way. So we can see here the grouped assets we identified in one of our buildings and the number of model objects. These are also the locations they're spread on and also the NRM categories that they belong to. We can see where these assets are coming from, what they are, and a lot of operational data that's associated with them. And we can really start heat mapping our information as we start adding our buildings and look at the different systems that come from our models and how those compare from one building to the next. And what is our aspiration is to be able to link our data to our BMS and also energy consumption data and our sustainability criteria. And we can do so by location as well and start really studying and understanding our buildings. And before I hand over to Chris, I'll just leave you with this diagram. This is the story of our current building, and what it illustrates is how we use classification to demonstrate what we need to maintain for compliance. So what we can see here is NRM level 1 objects, building fabric services, externals, finishes, furniture, fitting and equipment, the rough categories, broken down into their systems at NRM level 3, and then really going into sub-component and specification at level 4 or 5. And all those assets at the top are not assets we're interested in plant preventative maintenance. We would still like to know what they are so that we can understand our buildings, but what we really need to focus on is the maintainable assets at the bottom, and that's how we use classification and our model data to help us achieve this. And I'll hand over to Chris.
Right. So thank you very much, Ali. So I'm here today. I'm just going to give a very short case study on, I suppose, delivering these requirements across several projects, and I suppose some of the lessons that we learned throughout the process of developing these deliverables on 3 projects. So my name's Chris Johnson. I'm Digital Manager for Willmott Dixon Construction, so I head up the digital team there across our Midlands region. Now, us as a company, if you're not familiar with Willmott Dixon, we are a £1.5 billion turnover main contractor, and we have passionately embraced BIM. We've mandated across all our projects in our region, and we're really trying to sort of upskill our business to become a digital business for the future. So, very, very quick, brief introduction to the projects. We started off with working with Birmingham City University back in 2012 on the Parkside building. It was very early back in those days. I don't think the PAS 1192 Part 2 had actually even been released at that stage. So the team there had developed their own standards. Interesting enough, those standards very closely matched, I suppose, the principles that were being done by those standards very much closely matched what was being done in the PAS, but some of the details, I suppose, didn't quite, they weren't using quite the same classification systems. Then all these projects were 2-stage tenders. We then were awarded the Curzon building in 2014, and which is quite a large facility, £46 million facility. And then in 2016, we were then awarded the extension for Curzon there. Okay, so right at the very beginning, we first started off working with consultants working together in a 3D modelling environment. What's absolutely commonplace now on a lot of the projects wasn't happening commonplace back then. But there were a lot of advantages to having all your consultants working there in a 3D modelling environment, very quickly realising where there potentially are errors in that design right from the very start and designing around the other consultants' information. So, saves a lot of reworking and things like that. We get better coordination, but there is a bit of an impact, and I suppose it's only really starting we're coming to understand it now. By working in a 3D modelling environment, you realise very early on when another consultant's design is going to have an issue. So all those potential problems that would come out of the woodwork later on, maybe potentially during construction, they're getting resolved at the front end of that process. And what it actually does is it pushes a lot of the workload profile for the designers further forward in the process. So they start doing a lot of the work they did later on during stage 4 into stage 5 is now being done earlier on in stage 3. It's fantastic for us as a main contractor because we get a lot more information, more robust information for pricing, but then for a client, potentially you'll have to invest a bit more at risk before you go out to planning. So it's worthwhile being aware of that. Now, something we tried very early on, actually on first phase back in the Parkside building, was that now you've got all your models together, you can start doing the clash detection and automating the process and identifying potentially where there are issues. Now, first time we did it, we were a bit naive. We threw all the models together, clashed everything against everything. We ended up with 50,000 clashes on our project. We couldn't even open the clash file. It was a major headache. So we very quickly became aware that traditional coordination processes still need to be done on a project. The clash detection and things like that, any of these automated processes don't replace the traditional processes that a lead designer and design managers do. It just captures those things that used to occasionally slip through. So we end up with a better set of design information on site for construction. The other thing that we tried very early on as well is this thing, and we haven't really done it too much since, but we're starting to look at it more, about clash avoidance. Now, rather than getting that to a point where you then, clash detection is very reactive. You design something against or clash something against something else and you know where there's an issue. With clash avoidance, the idea is setting out a strategy right at the start of a project, allowing spaces for people to design within so that they can avoid clashes right from the outset. And we actually started it on the Parkside building, right back on, this is on the Curzon building, I think, I can't remember which one it was. But it's something we haven't really embraced as a wider business. But there were a lot of lessons we could have taken from this job and taken it forward. So the idea is we'll give a zone for M&E services. Whenever another, like a steel or something like that, goes through that zone, it's very quick and easy to pick up as there's potentially being an issue there. So you're giving spaces for people to design within. And it's actually something that's come out of the automotive industry. It's been in the British standards, but nobody seems to be doing it on our projects, and it's something we still need to look at and spend more time working on. Then once we've got those 3D models from the consultants, we can then pass them over to our team on the construction side and start using them to help better inform our processes about that project. So all we do is we take those consultants' models, we then add our logistics models and temporary works and things like that, and we link that to a Gantt chart. We simply take the objects, link it to the programs, the tasks in that program, and we just play through that program, and it acts like almost like an audit. If you've got a lot of objects left over after you've done this assigning to your program, you know you've missed a lot of tasks out. Or when you go through that actual construction simulation, you can very quickly see, oh, that doesn't make sense because that ground floor slab's going in after the columns are going up or something like that. Those things that potentially may not be easily evident in a very large program with tasks, and the context of all those tasks are so easily seen in a construction simulation. Now, we've actually been using it, I suppose, a little bit more than just sort of like a communication tool. We're now starting to use it as a rehearsal of the construction program. Taking a construction manager, sitting in with them, going through this construction rehearsal, task by task, talking about the activities that are happening on that task, and they can very quickly see all the context of all the other activities and potentially unconsidered things or health and safety considerations, etc., etc. So we're starting to use this rather than a construction simulation as a construction rehearsal tool, and it's really, really useful for that. So for some of the things that come out of the woodwork, so for example on the phase 2A or the Curzon extension, we had mast climbers going up, scaffolding going round, and very quickly we could see, it was very visually evident what wasn't evident in plans. At certain points in that program, it was going to clash with the scaffolding and those mast climbers weren't going to work. So we had to quickly come up with a new strategy. It's those kind of things that come out with that rehearsal. Now, this was an interesting point that after we handed over I'm just going to look at really a couple of key things here today because it's a very short case study. A couple of key things. One thing that came out of handing over the first phase of the BIM information to the Birmingham City University estate team, one of the team members asked our senior design manager, how do I know it's correct? Which is a very good question because, and Chris Kimman, who's our design manager, has been working on projects for 30 years, said, well, I've never actually been asked that in the last 30 years. So what happened on the second phase was that we were asked to undertake a point cloud scan to compare the actual install against the design intent. So we got an external company in, they did 2 scans, one of the structure and when their services, the above and below ground or below floor services were exposed, and then we did a second scan of the completed facility. We then overlay, we went around and looked at a lot of different software that you could do comparisons and things like that, and we quickly came to the conclusion, at least at that stage, it was just as easy to do it visually, mark up where those potentially variations were and send them back to the consultants to get them to update their information to make sure we could get an accurate set of as-built drawings and an accurate set of an as-built model. Because as I suppose customers, you're going to be using these models for the next 50 or for that lifetime of that facility, you'd want it to be accurate. So, a couple of interesting results. The architecture and the structure were surprisingly accurate. We had a 50 millimetre tolerance or something like that, and that all sat within those tolerances. It was the mechanical electrical services that were quite significantly out. Or actually really probably should say it was electrical services that were quite significantly out. And they took significant amount of time taking those information from those point clouds to go and revise their design to get it correct. It was at least 6 months or longer. Now, while we instructed the M&E main contractor, they of course also have tiers of subcontractors that work underneath them as well, and that message about they had to build within up to a 50 millimetre tolerance had never got through to those lower contractors, lower tier contractors. So interesting lesson, I suppose, for us. So by the time that we got on to the third phase and also onto the extension, we'd spent quite a bit of money going out to a consultant to go get those point clouds. In fact, it was as much money as going to buy a point cloud scanner ourselves, and we could start doing that process ourselves, having some of my digital engineers on site and start scanning as we go. Now, something we hadn't really occurred to us, but of course, scanning as you go, it allows us to then make sure that the quality control our supply chain partners as they are doing the install. So, petitioner will go through, do a level, we'd do a point cloud scan, drop it over the Revit model and quickly see where there were variations and where there were problems. We'd go back to the architect, associated architects. Where possible, they would incorporate them in the design and update the design information, reissue the drawings again for the following trades that were going to come along onto the job. Or if not, they'd tell us that there was a problem there and we'd go back to the supply chain partner and they'd update their works to correct it. So a really good example here, there was just a petition here that was, I think it was out by 100 mil, but the problem was that there were some glazed screens that were coming through here. They were already out for manufacture, so we were able to capture it, get this wall corrected before the glazed screens came to site, and we would have realised there had been a problem and we would have had to spend some time sort of working it out. So we're able to, I suppose, it gives everybody visibility into the quality of that design. It's a really, really useful tool for that, these point cloud scanners. It was my digital engineers who did it on this project and on our future projects, but this, I think, is going to be the way that our site engineer is going to be evolved to become part of their standard role on a day-to-day basis. Now, what we're starting to do now a bit is doing point cloud scans and then overlaying this is actually now one of our practitioners, we need to credit one of our competitors, but overlaying our mechanical electrical designs against what's actually, so we'll do a point cloud scan after we've got the structure up, we'll overlay the mechanical electrical design against that and then very quickly identify where there's going to be potential problems and get them sorted out before we encounter them on site. So it's a really, really useful tool. Now, one of the customer's requirements right from the start was to get a facilities management model that was able to be used on a mobile device. Now, that told us a really interesting vision here, and I think it's really valid, but because we didn't quite comprehend what the use of this would be. But the idea is, if there was a leak in a room somewhere, for example, say maybe we've got a leak over there in the corner, you could potentially, the estate manager out on site, because we're talking about university estate buildings here, they could be occupied lecture theatres and things like that. But the university estate manager out on site can very quickly go out on site with their model, bring up their mobile device with the model, turn off maybe the ceiling, trace it back to where the valve is without having to actually do an investigation by lifting ceiling tiles throughout different rooms, interrupting lectures and things like that, and immediately find where they need to turn something off. So having that mobile, there's a really good case for having that facilities management model actually out on site. We looked at a number of applications. Eventually, the estate team came back and they said they wanted this application called Valor, which got bought in the meantime, by the time we actually went out to get it ourselves, by Autodesk and became BIM4Estates Field. While it's a construction task management platform, I hadn't appreciated that a lot of the things that we do as main contractors out on site are almost identical to the things you do as facilities managers out in the field. Going through checklists, making sure that rooms are okay, we find issues, raising a ticket that we can go out to a supply chain partner to go get something fixed. So a system like this can be actually really good use of tool for being able to be used on site for management of that facility, having all the information there available to the team out on site. So what we've done is put barcodes on the equipment on site or barcodes on the doors. You scan that barcode, it takes you to that location in the model, you click on those items, and then it will take you back to the estates team's operational maintenance manuals and all the information that they have there. So it means that the people on site can immediately get that information that they need at that point. Now, it's not us that has done this study, but there was one of our competitors who has a facilities management arm, have done a study, and they found that using applications like this was saving them 30 minutes per call out. So there's quite significant potential savings there in operations. Now, I'm only going to talk about this very briefly, but this is, I suppose, what's actually turned out to be quite simple once you know how to do it. This was the trickiest part about the whole process for us on phase one. How do we create an asset-rich information model full of the information from our suppliers about all the products that have been installed on site and pull that into a model that's going to be fit for the estate teams to help to manage their information. So what we found is actually it's quite simple. We had to work through the process, but essentially we've taken a Revit model, we export it out to a spreadsheet using an application called BIM Link. That basically is broken down into the work packages. So what we do, at the front end of the Revit model, we have the Revit model, we set it up with all the parameters in that you're going to require for your information. So all the fields of information you need for managing or you want about that equipment. That's maybe blank. We take that, export it out to Excel using BIM Link. We then give that out to our supply chain partners. We break it up into the work packages, give them out a blank asset register to the supply chain partners. They complete that information. We then pull it back into the model using BIM Link, and it's as simple as that. We can then create a data-rich asset information model. So I suppose the couple of key things that we need to be aware of, our supply chain, some of them are really good with IT, others have very limited skill sets when it comes to IT. And so using all these different platforms and things like that we tested and tried by far the easiest way. Almost all of them could use Excel. So there was a massive advantage there. They've often been preparing information already in Excel that was going into O&Ms. So it's just a natural process for them to provide us an Excel spreadsheet. You need to make it contractual if you need to make it work, if you're going to get it to work, because as a contractor, you don't have any leverage over your supply chain partner if they say no. So the first thing we learned is that you have to get this incorporated into those contracts, and we have to make it as easy as possible. Okay, so when we got that information back, that's when my digital engineers, they'll go through, check it to make sure it's fit for purpose, and then we will hand it over to the customer at the end. Okay, the very last thing, what we started off in phase 2 is we had phase 2A I think it was, we set up in the cabin a digital space where our supply chain partners could come in and review that model if they didn't have, and they could walk through the model with our digital engineers and have a look at certain aspects or have a look at the construction simulation. So we'd regularly have like the cladders coming back in to look at certain difficult details and things like that. Now we've just sort of developed this, taken this one step further now, and we've now set up an immersive environment in one of our offices where we can take customers through on every project through at the stage 3 or stage 4 and walk through that proposed design. Now it's very interesting because I suppose as customers you look at a design from a very different point of view than what we do. So we've had customers come in, look at things like a quite well developed design and just simply ask, well, how am I going to change those lights? And nobody on our project teams asked that question. We can install it, but it's proven to be a really useful tool. We've also had people like, we've recently taken a customer through for a medium sort of size school. Everybody has been through those designs over and over again, but once we've taken them into this immersive environment and started walking them through that design proposal, they've immediately found 5 different things that could potentially impact on the operation of that school. So we've gone back, because we've taken them through early enough, been able to change that design, correct that design to get a better facility for that customer at the end. These immersive environments are proving really, really useful, and we can see it with stakeholders, we can see it with our teams, but we're now seeing what else we can use it for. So using it for collaborative planning sessions and things like that. All right, so thank you. Questions?